All right, let's jump right into it. Today, we're going to talk about one of the biggest shifts happening in AI right now, and that is the rise of the AI agent. So, you've probably heard the term thrown around. Everyone was saying 2024 was the year of the AI agent. But what does that actually mean? I mean, what even are they? And more importantly, what problem are they trying to solve? Let's get into it. Okay, so to really get what makes an agent so special, we first have to back up a little. We need to talk about what came before, and specifically, a really big problem with the standard AI models we're all used to. Picture this. You go to your favorite AI chatbot, and you ask it a super simple, personal question. How many vacation days do I have left? Seems easy enough, right? Well, spoiler alert, the answer you'd get would almost definitely be wrong. And you might be wondering why. It's because a standard large language model is what we call a monolithic system. Think of it like a genius who's only ever read a specific set of books. It only knows what's in its training data. It has no clue who you are. It definitely can't log into your company's HR system, and it has zero connection to your personal, real-time info. It's incredibly smart, but it's stuck inside a digital box. So naturally, the next step was figuring out how to get the AI out of that box. And that led to the first major evolution, moving away from those single models and towards something new called compound AI systems. And you can see the difference right here. On the one hand, you have that monolithic model we just talked about, totally isolated. But on the other hand, you have a system that's built around the model. And this is a game changer because this new system can actually connect to external things like databases or other tools. It's modular, which just means it's way more adaptable for specific jobs, and you don't have to retrain the whole giant model every time. Okay, so let's go back to our vacation question. How does this system handle it? Well, it's a totally different process. You ask the question, but this time, instead of just guessing an answer, the model is smart enough to create a database query. Then, the system takes that query, runs it on the actual HR database, pulls your real data, and hands it back to the model. The model then just has to turn that data into a normal human-sounding sentence. Boom, problem solved. You get the right answer. And by the way, this whole technique has a name you might have heard, Retrieval Augmented Generation, or RAG for short. But, of course, it's not that simple. This first solution, as great as it was, introduced a whole new problem. You see, this kind of system is really, really rigid. It's designed to follow one single pre-programmed path, and that's it. So what do you think happens when you go off script? What if you ask that same system a completely different kind of question? Something it wasn't designed for. Like, say, what's the weather in Florida? Yeah, you guessed it. It just fails. It throws an error. And the reason is that the control logic, the step-by-step instructions telling it what to do, was hard-coded by a person. Someone literally wrote code that says, Step 1, get question. Step 2, check vacation database. It has no other options. It can't adapt or change course at all. And this, right here, is the moment everything changes. This is the big agentic breakthrough. The core idea is, what if, instead of having a human programmer write that rigid step-by-step logic, we let the large language model itself figure out the best path to take? This is really the heart of it. On one side, you have programmatic control, which is all about thinking fast. It follows a fixed set of instructions, which is super efficient, but also super brittle. You change one thing, and it breaks. Agentic control, on the other hand, is about thinking slow. It's about giving the LLM a goal and letting it create the plan, and this is key, letting it adapt that plan if things change. That flexibility, that power to reason, that is what an AI agent is all about. So what does an AI actually need to be able to do this whole thinking slow thing? To act like a true agent? Let's pop the hood and take a look. Okay, number one, and this is the big one, reasoning. This is the magic of the core LLM. It's not just about spitting out an answer. It's the ability to look at a complicated problem, really understand it, and then break it down into a logical step-by-step plan. It's not just answering, it's genuinely strategizing. But hey, a great plan doesn't mean much if you can't actually do anything, right? So the second piece of the puzzle is acting. And the way an agent acts is by using a set of tools that we give it. And when I say tools, I mean pretty much anything you can imagine. It could be a simple web search to get real-time info, a calculator to do some math, the ability to query a database, just like in our earlier example, It could even be given access to run code or call out to other APIs or even other AI models. Basically, any program you can connect it to becomes a tool in its toolbox. And number three, an agent has to have memory. Now, memory can mean a couple of different things here. On one level, it's just the conversation history, so it remembers what you've been talking about. But it can also be its own internal scratch pad, sort of its thought process, that it can look back on to see what it's already tried, which helps it learn and self-correct if it hits a dead end. And this whole loop, the thinking, then doing, then thinking again, is often powered by a really popular framework you might hear about called React. The name says it all, right? It's a cycle of reasoning about what to do next and then acting on that thought using its tools. Okay, so that's a lot of moving parts. What's the actual payoff here? Why go through all this trouble? Let's take a look at a much more complex problem to see where an agent really shines. All right, let's go back to that Florida trip. But this time, I'm going to ask a way harder question, a question that needs multiple steps and different types of information to solve. The kind of thing that our earlier, simpler systems would have absolutely no chance with. An agent, though, an agent can totally handle this. It would, all on its own, come up with a plan that looks something like this. Step 1, I'll check my memory to see if we've talked about how long this trip is. Step 2, okay, now I'll use my search tool to check the UV forecast in Florida for those dates. Step 3, I'll use search again, but this time to find official health advice on how much sunscreen to use. And step 4, I'll fire up the calculator tool to do the final math. The key thing here is that no person had to code that exact sequence of steps. The agent figured it out by itself. So here is the single most important thing to take away from all of this. It's not that agents are just better than the old way of doing things. It's more like a sliding scale of autonomy. At one end, you have those programmatic systems. They're incredibly fast and efficient, but only for very specific, narrow jobs. And at the other end, you have agentic systems, which give you unbelievable flexibility for messy, complex problems where you can't predict every step. And the future really isn't about choosing one over the other. It's about using the right tool for the right job. If you have to answer 1,000 nearly identical customer support questions every hour, a super fast programmatic system is exactly what you want. But if you want to build an AI that can hunt down and fix a huge variety of software bugs on its own, well, an agentic system is really the only way you're going to get there. Look, this tech is still pretty new, but it is moving at an absolutely breakneck speed, which leaves us with a pretty cool question to think about. As these AI agents get smarter and more capable, what's the first really complex, thorny problem you would set one loose on?
Thank you. Share and subscribe to Learn AI for more AI insights.